This week class, you will be verifying trig identities. First, we want to talk about the different type of things that you've done in the past. Equality, a statement that is always true. So you see 2 is equal to 2, 3 plus 4 is equal to 7. Those things are easy to see. An equation, a statement that is conditionally true depending on the value of the variable. So you see 2x plus 3 equals 11. X minus 1 squared equals 25. There's exactly one variable that meets this condition. Now, identity is a statement that is always true no matter what the value of the variable. So, an identity is 2x plus 3x equals 5x. We can prove that. 4 times x minus 3 equals 4x minus 12. No matter what the value of x is, this quantity would be considered an identity. So that's what we're doing today. You took notes on reciprocal identities, quotient identities, and Pythagorean identities. These are the notes you need to have to work on the project of, not necessarily a project, but the problems that you're going to be assigned, okay? So this is preparing you for pre-cal. Those who are already in pre-cal, you've already seen these. So good luck, guys. Okay, we have our proofs for today is example 1. Here you're going to multiply sine theta times the quantity inside the parentheses. And this is what you get. So you look at everything and you say, hey, cosecant theta is the same as 1 over sine. So we change cosecant theta to 1 divided by sine theta. And we write everything down again. But sine theta times sine theta is just sine squared theta. Sines cancel, so I have 1 minus sine squared theta equals cosine squared theta. Since I'm subtracting sine squared, I can add sine squared to both sides. And that leaves me with 1 equals sine squared theta plus cosine squared theta, which is the same as sine squared theta plus cosine squared theta equals to 1, which is a Pythagorean identity. Example 2. We have secant squared x divided by tangent x. Change secant to cosine. Since it's secant squared, it'll be cosine squared theta divided by tangent. Wow, I put theta. That's okay. We can use theta instead of x. Tangent theta is the same as sine over cosine. So we're dividing by sine theta over cosine theta. And we write down cosine squared theta equals secant theta cosecant theta. Now when you divide, you have to change the multiplication and flip the quantities on the other side of the division sign. And so we have 1 over cosine squared theta times cosine over divided by sine. The cosines cancel, one of them at least. And we're left with 1 over cosine theta sine theta, which is equal to secant theta cosecant theta. Look at secant, it's 1 over cosine, and cosecant is 1 over sine. So that's the same thing as saying secant theta cosecant theta is equal to secant theta cosecant theta. So it's equal and it's proved. That was easy. What are the guidelines for verifying trigonometric identities? How do we do it? Your job is to prove one side of the identity is equal to the other side. Always work on the most complicated side. I know that sounds like it doesn't make sense, but it's important. If an expression can be multiplied, multiply it out. If an expression can be factor, factor it out. If you have a polynomial, split it. When in doubt, convert everything to sines and cosines. That's what we did on the first two examples. But always do something. Don't be afraid to create a complex fraction. We can do fractions. Your solution simply evolves. It's just as easy as that. Example 3. Ooh, this looks difficult. But see, I see cosecant theta. So I'm going to change it to 1 over sine. Notice I'm going to use x because they're interchangeable. Sine x. And secant squared will change to 1 over cosine squared equals secant squared x. So now I'm going to distribute the sine x. So I have sine x divided by sine x plus sine squared x divided by cosine squared x equals secant squared x. Notice that I simplified it. And now I'm going to multiply it by cosine squared x. So I have cosine squared x plus sine squared x equals secant squared x times cosine squared x. Secant squared is just 1 over cosine squared x. Those two quantities on the right-hand side of the equal sign cancel and become 1. So I'm left with cosine squared x plus sine squared x equals 1, which is a Pythagorean theorem identity. Not so difficult, right? The first thing you did was distribute the sine x. Then we simplified. That's how we got 1 plus. Then we multiplied by cosine squared x. And we finally ended up with the Pythagorean identity. This is what you'll be doing in class, in your work this week. Now is your turn.